Hello friends, welcome to my channel. I will teach you the subject of elementary grade examination which is called as plane geometry. This subject has 20 constructions divided into 4 headings as per the book. The materials we require for the basic constructions are scale, pencil, a compass with a different pencil. Do not use the same pencil for both drawing lines and in the compass, and also a protractor. So let's start with the first construction. The first question is bisect a line AB 5 centimeter long. So first, talking about the meaning of the word bisect. Bisect is basically they have given us a line segment A B. All lines run up to infinity, but when there is a given measurement of a particular line, it is called as a line segment and it has terminating points. This is the line AB and it is 5 centimeter long, and they have asked us to bisect this line. So bisect means basically dividing the line into two parts. So this bisection has to be done with the help of construction. So let's see how the construction is done. This is not the actual construction, this is just a reference diagram which can be drawn for the sake of understanding also in the exam, but kindly erase it after you. So here, with the help of scale, I am drawing a line segment which is 5 centimeter long and also drawing the terminating bars. Kindly label all the points in your construction. Your construction should be neat and clean. Now I will take the compass, keeping on point. First we will keep on A. Keeping on point A, assuming that this will be the half of line segment AB, I will take more than half but less than the full length of AB. Taking more than half, I will draw arcs above and below. Same way, from point B, I will cut the previous arcs, and now finally we have to join the point of intersections of these arcs. Drawing this arrow means that these lines are infinite. Let's label the points. This construction is complete. The concept and the basic meaning of this construction is drawing this perpendicular bisector bisects the line AB into two equal halves. So here, if we measure each half, we know that the half of 5 centimeter will be 2.5 and this is exactly 2.5. Same way, this part will also be 2.5. So this, in construction, we have bisected the line without the scale. Now moving further to the second construction. The question is, divide line AB 7 centimeter long into 4 equal parts. So this is an easy question after learning the first construction. Before, this was given as 5 centimeter, now it is given as 7, and they have told us to divide this line AB into 4 parts. So by applying simple logic, we can imagine that first we need to divide this AB into 2 parts, and further we can easily divide it into 4 parts by considering each half as 1. It is a bit complicated to understand, so let's construct. Here I am drawing a line segment. This time it is 7 centimeter long. Now, as we learned before, more than half from both the points A and B, and join the point of intersection of arcs. Now this line AB has been divided into two parts, part 1 and part 2. This is one part and this is another part, but in second construction we need to divide in 4 parts. So now I will consider AO as one part. I will just ignore BO for some time. Now considering only AO, I will repeat the same steps but not with the same radius. It should be less than full but more than half. So now we are considering AO, so I will take more than half as per AO, and from point A and O, not B, I will draw arcs. Same way I can repeat from point B and point O for the part BO. Now I will join the points and do not forget to label the points. The second construction is complete. This way we have divided the line segment AB into 4 parts. Part 1 is AI, part 2 IO, part 3 OJ and part 4 JB. Now let's move to the third construction. Construction number 3 is a bit complicated. It has to be regularly practiced or revised to remember till the exam. The question says, divide line AB 8 cm long into 6 equal parts. So they have given us a line segment which is AB and this is 6 cm long. So they have told us to divide this line into 6 equal parts. Now how do we divide? Why can't we use the previous method to divide this line into 6 equal parts? As we saw in the previous method, here we divided the line into 2 parts, into 4 parts. Now further, if I use the same method to divide more, then it will be divided into 1, 2, 3, 4, 5, 6, 7, 8 parts. And after 8 parts, it can be divided into 16 parts. So basically, the previous method can be used to divide the line progressively by multiplying it with 2, but here we need to divide the given line into 6 equal parts, which is not applicable for the previous method. So there is a different method now. The given line is 8 cm long. First we will draw a line segment AB 8 cm long. Now we need a protractor for this construction. I hope everyone knows the use of protractor. Still I will explain once. So there are degrees of angles marked in 2 bars. So the purpose of this marking is, suppose I need angle from point A. So if I consider the point A, the line is on the right side from point A. This is the central point in the protractor. I have to match this point with point A. Now, after matching this point A, I also need to make sure that these lines are coinciding with each other. Now, since the line is at the right side from point A, I need to start measuring from the 0 mark. Here is the 0 mark, 10 degree, 20 degree, 30 degree. For this construction, we need to make an angle of 30 degree. This is my angle CAB. Similarly, I have to make an angle downwards. So for this construction, we have made a line segment AB of 8 centimeter. After that, we have to make an angle upwards from point A and downwards from point B, but of the same measurement. So I will repeat the steps for point B. So now I will not hold the protractor this way because I need the angle in the downward direction. So I just have to rotate the protractor 180 degrees. I will match the point B with the line, and here is the 0 mark. From here I will look for 30 degrees. This is 30 degrees. Most students make the silly mistake. They will observe this bar and mark 30 degrees here. So here students can use simple logic that 30 degrees is not an obtuse angle, it is acute angle, so it will be less than 90 degree. I hope everyone knows about angles. Next step is to take a radius of 1 centimeter in the compass. I will keep it on point A. Now in the given question they have told us to divide this AB line into 6 parts. So I will mark 6 points starting from point A, point number 1, point number 2, point number 3, point number 4, 5 and 6. I will also number these points. Same way I will repeat the process from point B. Kindly observe how progressively the points have to be marked. This step should be done with the help of compass only and not with the help of scale, as expected in the examination. Now usually students get very confused while joining these points and they create a very spider web like thing, which is very common. So there is a simple technique I would suggest to use. So the last number on both the lines is number 6 and the name of the line segment is AB. So first of all, we can just join these points A and B with the last numbers, that is 6. Point A joining with 6 and point B joining with 6. Now it appears like a familiar parallelogram. So we can easily draw parallel lines into this parallelogram without making any mistakes. Kindly keep your diagrams precise, neat and clean. Here the construction number 3 is complete. Basically what we have done in this construction is, due to the drawing of these oblique lines, this line segment AB got divided into 6 equal parts. Part 1, part 2, part 3, part 4, part 5 and part 6. This is how the line has got divided. That is the reason we have done all this process. Once again revising, first we have drawn the line segment AB of 8 centimeter as mentioned in the question. Then we can take any angle. Here I have taken an angle of 30 degree which occupies a less space on the answer sheet. So 30 degree up from point A above and 30 degree below from point B. Then we took a radius of 1 centimeter in the compass and progressively did marking from point A. 1, 2, 3, 4, 5, 6. Similarly from point B on the below angle. And then we have joined point A with the last number and point B also with the last number, which had created a parallelogram, and in the parallelogram we joined other points drawing parallel lines. Due to the drawing of all these lines, our line segment AB got divided into 6 equal parts. Now moving to the fourth construction. Here we start with the construction of perpendicular lines. So what is the meaning of perpendicular? In simple words, it is just 90 degree. When there are two lines which intersect at a point and these two lines are perpendicular to each other, which means that these two lines intersect at 90 degrees. This is the meaning of perpendicular. So the fourth question is, line AB is 8 centimeter long. Point M is on the line AB at a distance of 5 centimeter from A. Draw a perpendicular to the line AB from point M. So they have given us a line AB which is 8 centimeter long. Point M is on line AB at a distance of 5 centimeter from A. So this entire line is 8 centimeter and AM is 5 centimeter, so BM will be 3 centimeter. Draw a perpendicular to line AB from point M. So from point M, they want us to draw a perpendicular line to point AB. Let's proceed to the construction. First we will draw the line segment. Which is 8 centimeter long. Name it as A, B as mentioned in the question. Now they have told us to consider a point M which is 5 centimeter from point A. Be precise with your measurements and avoid silly mistakes. This is point M, this point where the arc and the line segment meet. Now to construct a perpendicular line, we need to mark 2 points around M such that we can use these 2 points to make arcs. Let's construct for better understanding. Segment BM is shorter than AM as we can see. So I will take the compass radius according to the segment BM. So I will take more than half but less than full, and I will mark 2 points around point M this way. If you want, you can also complete this semicircle for better presentation. Kindly avoid this kind of imperfections. Now I will increase the radius and mark 2 arcs. These 2 arcs have to be marked from these 2 points. Let's label these points first, C and D. So we need to mark these 2 arcs from point C and D only, because that is the purpose of these 2 points. And we got point C and D from point M. Now we have to join the point of intersection of arcs with point M. This is the perpendicular from point M to the line AB. For confirmation, we can just measure. This is exactly 90 degrees. Here the construction is complete. Let's move to construction number 5. Line AB is 8 centimeter long. Point P is located at some distance above line AB. Draw a perpendicular to line AB from point P. So as mentioned in the question, there is a line AB which is 8 centimeter long. So in the previous fourth question, they had given us a point M on the line AB. But now in the fifth construction, they have asked us to assume any point P which is not on the line AB, but it is above the line. They can also mention in the question that this point is below the line, but the steps are the same for construction. So let's move to the construction. They have asked us to draw a perpendicular to the line AB from this point P. So now we have to draw a perpendicular, but there is no matching point over here anywhere. So we don't know how to draw a perpendicular, whether it will be like this way or this way or this way. It will be inaccurate if we draw free-handedly. So that is the reason we need to construct. So like in the previous question, from point M we made 2 points, that is C and D. Same way from point P we need to mark 2 points. If you want, you can only draw small arcs instead of a whole semicircle as per your comfort. Now we have got these new points, that is point C and point D. These are the points. Now from point C and point D, we have to take sufficient radius and draw 2 arcs without changing the radius of the compass for both the arcs. While drawing your constructions, kindly keep your main lines a bit dark as compared to the arcs for proper presentation. Now we can easily join point P with the point of intersection of these 2 arcs. So this is the perpendicular line to AB. Now let's move to construction number 6. Here we start with angles. So I will briefly explain about angles. Angle less than 90 degree is called acute angle. Angle which is 90 degrees in measurement is called as right angle, and angle which is measures more than 90 degree is called as obtuse angle. Now moving to the 6th construction. Question is, draw angle ABC of any measure and bisect it. So we can take any measure. Here I am taking an acute angle roughly of any measure. I am not using a protractor because they have mentioned in the question that we can free-handedly take an angle of any measure. This is a very easy construction after learning about lines. Kindly label your angle. This is angle ABC as given in the question. Now in the question they have told us that this is angle ABC. This is how they have represented in the question. So the meaning of this is, there are 3 alphabets. The alphabet which is in the middle is here, the middle point at the corner of the angle. So angle ABC means starting from the top, angle ABC. So that is how it has to be labeled. Moving to the construction, we have to keep the compass on point B. Roughly I am taking any radius in the compass and marking 2 points. Here also we can continue this circle this way. These 2 points are maybe D and E. Now we got these 2 points as D and E. Now any radius I will take, draw an arc, but while changing the point from E to D, for both the points E and D I have to keep the same radius as we did for lines. Now I have to join this with point B. This angle has been divided into two equal parts, as we can see. Now in this question they can also tell us, like lines, they can tell us to divide this into 4 equal parts. So I hope that should not be difficult. Again we can repeat the same process. And the angle has been divided into 4 parts. But for this question they had only told us to divide into 2 parts, so that was enough. Many students do not hold the compass properly. The correct way to hold the compass is at the tip. And while holding the compass, kindly keep this rod perpendicular to the plane of the page, so that pressure can be easily applied on this part, and this part is free and easily movable, so circles can be drawn without any disturbance. Mostly students hold this way, so that can easily change the radius of the compass. Do not hold this way. This is the correct way. Let's move to the 7th construction. Draw a right angle ABC and trisect it. So here they have given us the measurement of the angle. Now I am drawing a base of the angle of any measure. Then with the use of protractor, I will mark an angle of 90 degrees. This is also a very easy construction, but students tend to forget. Now the meaning of bisect was divided into 2 parts because the word bi was included. So in this question they have asked us to trisect the angle. So there is a word tri, which means 3. So we need to divide it into 3 parts. I am keeping the compass. Let's label first. Then keeping the compass on point B, which is the central point, I will take enough radius and holding the compass in the right way, I will draw a circle. For this question, drawing a quarter of the circle is mandatory because with the help of this we are going to trisect. So I have drawn this arc of the circle. Now I will not change the radius. This is a very important step for this construction. Without changing the radius, I need to keep on this point and cut this arc. Same way I will keep on this point. I will revise once. We had drawn angle ABC, which is a right angle. Then with any radius, I have drawn a big arc cutting the arms of this angle ABC. Now I will label these first. I got 2 points, that is point D and point E. Now with point D and E, keeping the compass on these 2 points but with the same radius as of this, I had drawn 2 arcs, from point E this arc and from point D this arc. I again got 2 points. Now I will join these 2 points with point B. So these 2 lines have divided angle ABC into 3 parts, that is 1, 2 and 3. These are the 3 parts. Let's move to construction number 8. Now from construction number 8 we start with the construction of triangles. So let me tell in brief about triangles. There are 3 types of triangles. A triangle whose 3 sides are equal is called as an equilateral triangle. A triangle whose two sides are equal but the third side is different is called as isosceles triangle, and a triangle of which all three sides measure differently is called as a scalene triangle. So now in the construction number 8 they have asked us to construct an equilateral triangle. The question says construct an equilateral triangle on the given line 4 centimeter long. So they have given us a line which is 4 centimeter long and they have told us to construct a triangle on this. So basically if they are telling us that we need to construct a triangle on this 4 centimeter line, then logically this 4 centimeter line is the base of the triangle. As simple as that. Now to construct an equilateral triangle. Now they have only given us the measure of the base and they have only mentioned that this is an equilateral triangle. So the other two sides will also be measuring 4 centimeter only. I will take a radius of 4 centimeter in the compass. Keeping on both the points, I will draw arcs. And join this point with both the endings of the base of the triangle. The construction is complete. This was a very simple construction because it was an equilateral triangle. Let's move to construction number 9. In construction number 9, they have asked us to construct an isosceles triangle. Construct an isosceles triangle with one of the equal sides being 5 centimeter long and one of the equal angles being 65 degrees. So there are some properties of an isosceles triangle, out of which there are two main properties. As I told you, the two sides of an isosceles triangle are equal but the third side measures different. Also along with this, the angles made by the two equal sides, that means this angle and this angle, not necessarily that this angle will also always be on the base. A triangle can be this way also, in which these two sides are same and this one is the different one. So in this case the same angles would be this. So these two angles would be equal. This is the second property of an isosceles triangle. So in the question they have given as one of the equal sides, which is mentioned as 5 centimeter, and one of the equal angles as 65 degrees. Not that difficult construction, but students tend to forget this one. So in this construction they have not given us the measurement of the base of the triangle, so I will take of any measure. Now with the help of the protractor I will measure 65 degrees. Because one of the two angles is 65 degrees. We have constructed the angle that was 65 degrees. Now let's move to the side. One of the sides is given as 5 centimeter. The radius 5 centimeter. I will keep, let us first label so that it will be easy to explain. I will keep on point B. From here I will put an arc at 5 centimeter which is the radius of my compass. Now from the point of this arc I will keep the compass here and I will draw another arc on this line. You can also extend this arc to point B to confirm that your construction is going in the right direction. If this arc is passing through this point B, then your construction is right. If your arc is coming inside the point B this way or too far from point B this way, then something is wrong. Now we need to join this point and this point. To to complete our triangle. This is how the construction is done. So now if we measure, these two sides would be 5 centimeter and these two angles would be 65 degrees. Moving to construction number 10. Construct a triangle with its base 5 cm long and the angles at the base are 60 degree and 70 degree respectively. This is also a very easy construction. They have given the base of the triangle, which is 5 cm long. After making the base, they have already given us the two angles at the base, one of which is 60 degree and other is 70 degree. So assuming that angle over here would be 60 and here it would be 70, I will use the protractor. 60 degree angle can also be constructed, but in this question it is not necessary. I have marked on 60 degree from this side, and from the other side I will mark at 70 degrees. To avoid confusion of joining the lines to the wrong markings, you can first make one marking and join and then make another. This is 60 degrees and 70 degrees. Construction number 10 is complete. Moving to construction number 11. Construct a triangle with its three sides as 5 cm, 7 cm and 4 cm long. So looking at this data, we can easily understand this is a scalene triangle. So I will take the central data as the base of the triangle. 7 cm I am taking as the base. Now we cannot easily use the ruler for making 5 cm and 4 cm lines. I am using a compass again, taking a radius of 5 cm. I will keep on this point and make an arc of 5 cm radius. Again I will change radius to 4 cm this time, and from the other end of the base I will cut the previous arc. Now joining these two points with the terminal parts of the baseline and completing the scalene triangle. The construction has been completed. For better presentation, we can write the measurements of the triangle as it is a scalene triangle. Let's move to the third headline, which is construction of squares, starting from the construction number 12. Now in case some students have a loose rounder or their compass becomes loose after a period of using, then you can just use a screwdriver and tighten it. So your radius and construction would remain accurate. Moving to the construction, as the question says, construct a square with side 4 cm long. Properties of a square, as everyone knows, all sides of all squares are equal. So if one side is 4, the other three sides will also be 4. All angles of a square are right angles, and the diagonals of a square. The meaning of diagonals is when we internally join two vertices of any shape, they form the diagonals of that shape. So the two diagonals of the square intersect each other at right angle. These are the three important properties of a square. Now let's move to the construction number 12. they have told us to construct a square with one side being 4 centimeter. So that means all the sides of this square are 4 centimeter. Now we can easily draw this square with the help of the ruler, but that would not be accurate. So let's construct as it is expected in the exam. First I will draw a line of any measure for now. Considering this line, I will mark a point A from some distance on this line and point B at the terminal end. Now from this point A, I will just construct a perpendicular line as taught in construction number 4. Why I am drawing a perpendicular line? Because it will be this angle of this square. So it should be a right angle. That's why I need to draw a perpendicular from point A. I am repeating the same steps as that of construction number 4 for drawing this perpendicular from point A. Now I will take a radius of 4 centimeter. 4 centimeter because one side of the square is given as 4 centimeter. After taking the radius as 4 centimeter, I will mark from point A on this line at 4 centimeter and on this line as 4. Now after getting these 2 points, I will label this as C and D. Now from point C, without changing the radius, with 4 centimeter radius only, I will draw another arc, and same from point D, I will draw one more arc. Now I will join all the points to form a square. The construction has been completed. Labeling all the points in your construction is a very important step. Do not forget. Now moving further to construction number 13. Construct a square with its diagonal measuring 9 centimeter in length. So as I told you, the diagonals of a square intersect each other at right angles, and also there are 2 diagonals to all squares, and these 2 diagonals are always equal. So here in the question they have given one of the diagonals as 9 centimeter and they have asked us to construct a square. No more data is given except this measurement of the diagonal. So let's take this diagonal as the base of the square, because not necessarily a square always has to be drawn this way only. We can also draw a square this way in an oblique plane. This is also correct. So I will take the diagonal 9 centimeter as the base. Now I will label this and I will bisect this by perpendicular bisector method as in construction number 1. Join the points. Now my square is going to look like this. So all these 4 sides are going to be equal, but they have not given us the sides. So I will take the help of this diagonal only. So now we know that these 2 diagonals are equal in a square. So which also means that if I consider this part is going to be equal to this part and this part and this part. So all these 4 parts are also equal, which means that this and this part is equal because we have drawn the perpendicular bisector. So these 2 parts are equal. So I can just take this as the radius, OA as the radius, and keeping the compass on point O only, I can draw arcs on this line above and below. Now I have got these 2 points. Kindly pay attention that these 2 points are not the points on which we had drawn these arcs. These are the different points. This point is over here. Not necessarily for all the students' constructions this will be equal. These two are different points. Now I will draw lines to join all the points to form a square. Here the construction is complete and ACBD is the required square. Here these are the two diagonals. Each diagonal measures 9 cm. Hope that your concepts are clear. Moving to construction number 14. Construct a rectangle with its two unequal sides measuring 5 cm and 8 cm respectively. Let's talk about rectangle first. So a rectangle looks somehow like this. Talking about the properties of rectangle, the opposite sides in all rectangles are equal. And there are two diagonals in rectangle and both of these diagonals are equal, but as in like square, these diagonals do not meet at right angles. Let's move to the construction. They have given two unequal sides measuring, one is of 5 cm and one of 8 cm. Focus on the word unequal. So this word unequal tells us that they are giving us one as the length and the other as the breadth. That is the reason they have used the word unequal. Now we got the two sides. Now we can easily form a rectangle because the opposite sides would be equal. This side would be 5 cm and the other side would be 8 cm. Let's move to the construction. I will again take any line of any measure. Assume 2 points A and B somewhere in the middle of this line, which will be of 8 cm. So AB should be of 8 cm. If this is point A, this is point B, this distance is 8 cm. Now these angles, there are 4 angles in a rectangle and all 4 are right angles. So I again will have to draw perpendiculars from points A and B as we did in question 4. Here I can extend the line so that both the line and the arc will intersect and I will get a point. I got these 4 points. Now taking sufficient radius, and without changing the radius, again I will draw arcs. Now I will join the points. These are the perpendicular lines from point A and point B. Now we need the fourth side of the rectangle, but we do not know whether we should draw it from here or here. So as we know that these two sides measure 5 cm. So what we have to do is just make arcs or markings with the help of arcs at 5 cm from points A and point B. So this is 5 cm and 5 cm. The construction is complete. moving to question number 15. Question 15 says, draw a circle of radius 2 cm and divide it into 4 equal parts. So as given in the question, I will take a radius of 2 cm and draw a circle. Now I will draw any one of the diameter of the circle. So diameter is a line which passes through the center. So the center of the circle was over here, the point where I kept the compass, the needle of the compass. Now this diameter is passing through the center of the circle. After drawing this diameter, we need to repeat the same steps as we did during line bisection. That is, take a radius of more than half, draw arcs above and below. Similarly, from the other side, drawing arcs above and below. Join the points. And label the points. The circle has been divided into 4 equal parts. So basically in this question we have constructed 2 diameters of the circle, one which we have drawn free-handedly and the other was a perpendicular bisector. Now, like in the previous question, we divided a circle into 4 equal parts. Further, we can divide the same circle into 8 equal parts using angle bisection. Every 90-degree angle can be further divided into 45 and then we can again draw lines. Then the circle will be divided into 8 equal parts. Draw a circle of radius 3 cm and divide it into 6 equal parts. So first let's draw a circle of radius 3 cm. Now, first step is common in all the circles. A diameter passing through the center of the circle. Now let's label this as point A, B, and this is the center of the circle, O. Now the procedure for division of this circle into 6 equal parts is slightly different. We have drawn the circle with radius 3 cm. So without changing the radius, I will keep on either point A or either point B and I will draw arcs. Arc number 1, arc number 2. Now if we observe, arc number 3 will coincide with point A. So I will not draw it. Again from the other side, 2 arcs. Now I will just join the opposite arc points. And label the diagram. So here if we observe, the circle has got divided into 6 equal parts. Divide a circle of radius 3 cm into 8 equal parts. I am taking a radius of 3 cm in compass and drawing a circle. Again we need to draw a diameter of the circle. Repeat the steps. Now we have repeated the same steps as in the above circle, but we need to divide this circle in 8 equal parts. So now I will divide each angle using angle bisection. So here I don't have to divide all the 4 angles. Even if I divide 2 of the angles, I will get 2 bisectors. Let's construct and see. Now assuming this as an angle, as we learned angle bisection in construction number 6, assuming the as, let's label for the sake of understanding. So if I assume AOB as one angle, I need to mark 2 points on this angle as we have seen in construction number 6. So I've marked 2 points. Now I will take sufficient radius to draw arcs from these 2 points. Now when I join this point with the center of the circle, it will bisect the angle AOB. But what I will do is, I will continue this line to bisect angle DOC also. Similarly, I will repeat for angle AOD. Now, for angle AOD, I need arcs on this line and this line. So while doing for this angle, I already got an arc on this line. So I will take the same radius on this line also. So what you can do, while marking for these 2 lines, you can rotate the compass on line DO also. Now again I will take sufficient radius. I will draw an arc. Then without changing the radius, I will draw another arc and join and extend. So now we can see the circle has been divided into 8 equal parts, 4 above and 4 below the principal diameter. So in circles there are 3 types of constructions. One is a normal one in which we are dividing the circle into 4 equal parts. The second construction is dividing the circle into 6 equal parts, and third one is dividing into 8 equal parts. The first and third construction is using the same method, and second construction is by using a different method. Without changing the radius of the compass, we are taking radius of 3 cm only and constructing the whole diagram. But in construction number 1 and 3, we are using angle bisectors to divide the circle into 4 and 8 parts. Now let's move to question number 16. Now question number 16 is construction of a pentagon. This is a quite complicated one. Construct a regular pentagon with one side measuring 4 cm in length. So what is the meaning of a regular pentagon? Why are they using the word regular? They are using it to specify that all the sides of this pentagon are of equal measurement, one of which they are giving us as 4 cm. So all the sides of this pentagon is going to be 4 cm. So step number 1, I will draw a line segment of 4 cm first, and I will draw perpendicular bisector using angle bisection only. Now I will draw a semicircle on the base, which was 4 cm. Make sure that this construction is very accurate and precise, as small changes may make a big difference in the final diagram. So AOB with radius as OA, I have drawn a semicircle on the line AB, and this is the perpendicular bisector. Now for this construction, As per the book, we have to start labeling the points from the number 4. So this first point is labeled as number 4. Let's move forward. Now, before we had kept the compass on point O to draw the semicircle with the radius OA, now I will keep the point of the compass on A and take radius as AB, which was 4 centimeter. Now I will just draw an arc which is intersecting the perpendicular bisector this way, and this point of intersection I will label it as point 6. So now you must be having a question. We have labeled the previous point as 4. Now directly we are labeling as 6. So we need some point over here in between, which is point number 5. So for that point, we will just construct again a line bisector this way. So not necessarily a line bisector should always be vertical. I can assume this 4, 6 as a line segment and make a perpendicular bisector this way. For clear understanding and to avoid confusion, you can also tilt your book 90 degrees so that this line appears to you as a sleeping line, something like this, and then we just have to bisect this line to draw a perpendicular bisector. The same thing I am going to do over here. I will take more than half. I will draw arcs on both the sides of the line and repeat the same from the other point without changing the radius of the compass. Now join the points. Here we got point number 5. So now we have got all the necessary points. Now is the most important step for which we have done all of this construction. This point 5 is the main point which was required, and that is the reason we constructed for point 4 and 6. So we have done working on point 4 and 6. So now what we need is point 5. So I'm keeping the compass on point 5, taking the radius as 5a. Kindly observe, taking the radius as 5a, I will just draw a whole circle. As you can see, this circle is easily passing through point B, point A. Now the complicated part is over. We will take a radius of AB, draw arc from point A and point B, and I will extend this perpendicular bisector further to meet the circumference of the circle. Now I will join all the points to form a pentagon. Pentagon is a 5-sided figure, and here we have got 5 sides of the regular pentagon. Let's move to part 2. Construct a regular heptagon with one of its sides 4 cm long. So as we have seen, pentagon is a 5-sided figure, 5-sided polygon. A polygon is any closed figure with infinite number of sides. Even a circle is a polygon. So this is the theory part, but here they have asked us to construct a heptagon. So hepta means 7. So they have asked us to construct a 7-sided polygon. So this construction is almost similar to part 1. So let's start. As they have given one of the sides being 4 cm, I will make a line segment 4 cm long. Again I will repeat the steps. I will draw perpendicular bisector to this line by drawing arcs above and below from both the terminal ends. Join. Repeat the same steps as in previous construction. We will draw a semicircle. As in the previous construction, we will label this as 0.4. Now, taking the radius as 4 centimeter, draw an arc. This point, label it as 6. Now, for getting a 0.5 in between 0.4 and 0.6, follow the steps of line bisection as we did in the previous construction. Join the points. This is 0.5. Till now all the steps were similar to the previous construction. Now taking the radius as 4, 5 or 5, 6, both are equal, we need to mark one more additional point, which is 0.7. So for pentagon we had to mark 6 points, and for heptagon we are marking 7 points. Now taking the radius as 7a, let's mark this as A O B. Taking the radius as 7a, we have to draw a circle passing through points A and B. I will extend the line of perpendicular bisector. Now we have to take the radius as AB, because as mentioned in the question, this is going to be a regular heptagon. Taking AB as the radius, we will draw arcs from points A and B and continue the arcs using the previous arcs. Join all the points to form the heptagon. Label the points. In the previous diagram also, we need to label all the points. The construction is complete. These two constructions are very important, and every year there is at least one question out of the two. The process is almost same till 0.6. Now we are moving forward to the fifth and the last heading, which is inscribing circles. Moving to question number 17. Construct a triangle with its three sides measuring 4 cm, 5 cm and 6 cm and inscribe a circle in it. So as we have learned in construction number 11, this is a scalene triangle and the given measurements are 4, 5 and 6. So I am taking the central number as the base of the triangle. So first I will draw a line segment of 5 cm. Taking a radius of 4 cm in the compass, draw an arc and taking a radius of 6 cm, draw another arc to cut the previous arc. If the arcs do not cut each other, you can extend them. Join all the points to form the triangle. Now the next step for inscribing a circle is angle bisecting. So here I will bisect two base angles of the triangle. Any two angles bisection is enough. So as we have learned in angle bisection, I will mark the 2 points. And using the 2 points, I will draw 2 arcs and join it. So if this is triangle ABC, then ACB is an angle which I have just bisected. Now let us bisect another angle which is ABC. Join it with point B. Angle ABC and ACB have been bisected. Now the next step is to consider this as a point O. As we have learned in construction number 5, we can consider this point O as an external point to the line BC. Now from this external point, we need to construct a perpendicular to the line BC. So we need to again mark 2 points using 2 arcs of appropriate radius. Now using these 2 points, I will again draw 2 arcs to intersect each other and join it with point O. Now this line is perpendicular to the line BC. Taking OM as the new radius, taking OM as the radius, I will draw a circle which is perfectly getting inscribed into the triangle. This kind of gap is to be avoided. This is due to the minor inaccuracies during the construction. So make sure that this is accurate. This circle also touches the third side of the triangle. The meaning of the word inscribe is in, meaning inside, scribe, to describe. So inscribe is the means that they have given us a triangle and we need to draw a circle inside the triangle, touching all the 3 sides of the triangle. Moving to the next construction. Construction number 18. Question is, construct a square with side 6 cm in length and inscribe a circle touching all its 4 sides. First, we will construct a square of side 6 cm as we have learned in the construction of squares. Draw a line of any measure. Mark point B at second terminal end and at 6 cm, which is the given side of the square. Mark point A. Now from point A, we will draw perpendicular bisector. Sorry, not bisector. We will draw a perpendicular line from point A Now on this perpendicular line, we will take a radius of 6 cm and make an arc from point A. Now keeping the compass on this arc, we will again make another arc, and from point B, we will cut this previous arc. Join all the points to form a square. This is the required square. Now, as per the question, inside the square we are supposed to inscribe a circle. So first of all, we will draw the two diagonals of a square, that is match the two vertices of the square internally. Let's consider this as point O. Label the remaining points also. Now again we can consider point O as the external point as compared to AB line. So from this point O, we have to again construct a perpendicular line. Now taking OM as the radius, we have to draw a circle inscribing into the square. Let's move to the next construction. Construction number 19. Inscribe 3 equal circles in an equilateral triangle with one side 9 cm long such that each circle touches one side of the triangle and two other circles. So now they have given us an equilateral triangle in which one side measures 9 cm and they have told us to inscribe 3 such circles that, focus on the words in the question, one circle touches two other circles as mentioned in the question. So let's construct now. First I will draw the base of the triangle, which is again 9 cm long. So let's draw a line segment. Now taking the radius as 9 cm as per the construction of an equilateral triangle, I have to make two arcs from two terminal points and join all the points to form a triangle. Let's label this triangle as triangle ABC. Now I will draw two angle bisectors of the two basal angles. So here I am bisecting the two angles at the base. Now I am joining this point O with A and extending it further downwards till I reach point M. Now once again I will bisect this angle OBM. Let's consider this new point as point P. Now the construction is almost done. Taking OP or PM as the radius, I will draw a circle. Now I do not have any center over here to draw a circle, so take this point O as the center and draw a principal circle first before starting to inscribing the three circles. Now I get the 3 points, point 1, point 2 and point 3, which are going to be the centers of the three circles, point P, Q and R are going to be the centers of our 3 inscribed circles. Now taking Q as the center with the same radius, which is OP, and taking R as the center, I will draw the third circle. This way we have to inscribe 3 circles inside the equilateral triangle. Revising all the steps, first we have constructed the equilateral triangle. After the construction of equilateral triangle, we have bisected the 2 base angles and joined the point of intersection of the 2 bisections with point A and further extended to meet line BC to point M. Now we have bisected angle OBM. The angle bisected meets line OM at point P. Taking OP as the radius, we have made the central circle to get the center points of the circle as PQR, and taking these 3 centers, we have inscribed the 3 circles inside the equilateral triangle. Moving to the last construction, which is construction number 20. Inscribe 4 equal circles in a square with side 8 cm long so that each circle touches one side of the square and other 2 circles. So they have given us a square of side 8 cm and they have asked us to inscribe 4 circles in this square so that each circle touches one side of the square and 2 other circles. So let's start with the construction. First I will draw a base, mark points AB, take a radius of 8 cm, draw an arc from point B, this is point A. From point A, construct a perpendicular line. Again take a radius of 8 cm. Every time you have to construct the square, not assume and draw with the help of a scale. That square would not be accurate and the inscribing will not be precise. The square is ready. Now we will draw the 2 diagonals of the square. Mark the middle point as O. Now I will construct a perpendicular from point O. So as you can see, more or less we are repeating the same steps in every construction. I will extend this to meet the top side. Let's label all the points. Similarly, I will also construct a line this way. You can also measure if one side is 8 cm, then you can make markings on 4 cm and 4 cm on opposite sides and join. But the line while joining should pass through the center O. Now again we will bisect this angle OAM. As we did previously in the triangle, we bisected OBM. So the base angle has to be bisected. Naming this new point as P. Now I will take the radius as OP and draw the main central circle, which will give us the center points of all 4 circles. If this point is P, let's label this as Q, R and These are the center points of our 4 circles. Now taking the radius as OM or OP. I will start inscribing circles in the square. Minor inaccuracies can be rectified by changing the radius of the compass. Here the construction is completed, and here we complete with the subject plane geometry for elementary exam. Thank you.